So this is part two of our discussion of Darwin. And we talked a little bit about some of his influences and talked a little bit about some of the history in the context of his discoveries. And I hope you've read your McClellan and Dorn on Darwin as well, so that some of what this video will suggest is just an overview of McClellan and Dorn's interpretation of Darwin. So we're going to just hit the high points, if you will. So, The Origin of Species by Means of Natural Selection. This was the book in 1859 that Darwin published that garnered a lot of attention. He first lays out how farmers and animal breeders have produced domesticated varieties of species by artificial selection. We might call this animal husbandry, we might call this domestication of plants and animals, yeah? So, for example, dogs. You may know that most theory suggests that almost all common domesticated animals are derived from wolf ancestors. So Darwin is quick to suggest that most of the breeds of dogs in England, for example, are the product of breeding, that we have taken various dogs and bred them for specific purposes, for work, for hunting, for companionship, etc. So he makes that argument. Pigeons as well in England. Pigeons were developed for a lot of purposes to, in particular, to do things like communication, carrier pigeons, right? To be homing pigeons, to come and go. And so even pigeons have been domesticated and bred in a certain way. Certainly grains. You saw the video in the video of GMOs from the CBS Sunday Morning Show, where it talks about corn in particular, that there's natural wild corn that maybe originates in North America, in Mexico, in Central America, and that the corn we have today is a product of artificial selection, that we have tried to make those ears of corn larger, those grains larger, right? So he suggests we've been doing this for quite some time in human history. In order to appreciate and understand the fundamental arguments, the fundamental elements of his argument, you have to understand the idea of variation, you have to understand the idea of struggle for existence, and you have to understand the idea of natural selection. All three lead to species change, right? Within each species, there are variations. They might be as simple as height for humans, beak shape for birds, as Darwin suggested with the various finches he found on the Galapagos, right? That there's certain variations. And we'll stick with a beak shape for finches, and that certain beak shapes allowed for easier access of certain foodstuffs, right? So if a longer beak might allow certain access to certain kinds of foods, a shorter, stronger beak might allow the ability to open nuts, to crush grains, if you will. So you have to understand variation. You have to understand or accept that there is a struggle for existence, that there might be a shortage of resources, or it might be difficult to get the resources a particular group needs to succeed, and that there will be competition, and that those variations might help in that competition. And then finally, there's natural selection, the idea that those particular members of the group with a certain variation succeed in this struggle for existence, and then they propagate themselves. They have children. They have offspring that carry that same variation. Yeah? All three, he says, are necessary for species change, to see a change within a species. So these are the fundamental elements of his argument. And from McClellan and Dorn, and also from Darwin, we get this concept. Through a process of natural selection, the best equipped individuals will reproduce at a higher rate, thus diverging from the ancestral stock, thereby in the long range produce species change. So it's these variations that allow a particular member, a particular individual to be best equipped, and that best equipped individual will reproduce and thereby diverge, maybe just a little bit, from the original ancestral stock, Interesting words, yeah? And thereby, in the long range, produce species change. And it does take a long time. Darwin, you should know, was his own harshest critic. He laid out challenges to his own theory, right? And good scientists will do this, right? They'll lay out challenges to their own theory. How could incremental change, tiny, tiny change over a long range of time, right, lead to perfection? In particular, he gives the example of the eyes of birds of prey, such as the eagle, the falcon, that these eyes are so good at finding prey at long distances. These are perfect eyes. Do they no longer evolve over time? And so how can incremental change lead to perfection? And perfection by its nature means we don't change anymore. That's it, right? Or how can incremental change lead to odd behaviors? And in this case, he's talking about the cuckoo. You may know the odd behavior of the cuckoo bird. The cuckoo bird will lay its eggs in another bird's nest and have that bird raise its offspring. That seems strange behavior if one wants one's offspring to succeed, right? It seems to be almost abandoning the offspring. So again, how can incremental change lead to some of these strange things that we see? The fossil record is incomplete. So we are just now in Darwin's time starting to build a fossil record. And the fossil record is incomplete in his time, and so therefore there is no empirical proof, or the proof behind his theory cannot be shown empirically, right? So that's a problem. Still, it's difficult to explain all we observe with the theory of a single creation. And that's the dominant paradigm, right? That's the dominant thinking. There's a single creation, all animals, all plants, all humans created at the same time. There's not really any extinctions. It's just a sort of static nature, world of nature. Again, you can take a look at page 335 of McClellan and Dorn right there. Some of the examples that he offers to support, however, his theory. So he's arguing against that his theory is correct, but he also offers some examples of how it could be correct. And he talks about things that we have in our bodies, humans at least, that we really just don't need anymore, that indicate that once upon a time we needed these things, but we don't need them anymore, or we have no use for them anymore because we have evolved, we have changed. Different things have happened to create change within our species. So, for example, he talks about erector pili. We would call these goosebumps and body hair that when we get worried or we get upset, these goosebumps go into action. Now, some of us have them more demonstrated than others. Wisdom teeth. The human jaw has become smaller because we don't need to eat the kinds of things we used to have to eat to survive. And those wisdom teeth come in the back there, right? And they're good for shredding and doing all kinds of great chewing, but we just don't need them anymore. Don't need them anymore. This image is to show you a demonstration on the erector pili, and the best example, and I like the image of the cat. When a cat, if you're familiar with cats, when they get angry or get frightened, their hair stands on edge, and it's meant to make them look larger or frightening, or to warn someone that I'm bigger than you might have thought, I'm meaner than you might have thought. And again, for humans, we have the same reaction, but we just don't have the long body hair to affect that look. This is another chart that I like for explaining. For some people, it works well, for others not, but let's just run through it real quick. So for example, talking about wisdom teeth, in the human body, organs such as the appendix, the wisdom teeth, serve no known purpose, yet continue to exist in the body. Right, so they have a lack of biotic potential. Right, so we really don't need them anymore. All organisms possess unnecessary structures, and due to that lack of genetic variation, the genes for the structures are passed on. So the genes continue to be passed on. Lack of genetic variation. Due to lack of genetic variation, the genes for the unnecessary structure are passed to every offspring. The constant passing of these genes creates a lack of change in a population. Therefore, because there is no change in the population, there is a lack of evolutionary mechanism to do away with the unnecessary structures. So we're trying to argue why it is that we still have these things. Why didn't they go away? And it all comes down to the fact that all organisms possess unnecessary structures, and due to that lack of genetic variation, the genes for the structure are passed on. Due to the lack of genetic variation, the genes for the unnecessary structure are passed to every offspring. The constant passing of these genes creates a lack of change in the population and a lack of evolutionary mechanism to do away with unnecessary structures. So we have these vestigial organs, we have these wisdom teeth, because we don't, in the process of natural selection, there's no way to get rid of them, if that makes sense. It's the descent of man that really got people talking in 1871. So this is the second work of Darwin. And in this work, he argues that there is a human connection to an ape-like ancestor. Evolution played a role in human development. He argues the development of instinct, of behavior, our human intellect, our human emotions, and even morality. These are bold statements, to be sure. Again, McClellan and Dorn will go through this work in more detail. So human connection to an ape-like ancestor, evolution played a role in human development of instinct, behavior, intellect, emotions, and morality. Fascinating arguments that he's making. So what are the results of his publication? In his lifetime, Darwin's lifetime, he did not win universal acceptance in the scientific community. He did not win universal acceptance. You can tell from this image here, this is a political cartoon that suggests that you have the head of Darwin on the body of a chimp, that he's somehow evolving right before our eyes, right? There was a lot of criticism for his theory. There was little fossil evidence to support it. As you well know today, that fossil evidence has been filling out more and more. It is still not complete to be sure. It is still not complete to be sure. But much like Einstein's theory with regard to gravity and gravitational waves has just been detected just this year, and we'll have more on that. More and more of the evidence necessary to put the pieces together in Darwin's theory come to light on a regular basis. Controversial? Yes. Even in his own day, physicists detracted from him. In particular, Lord Kelvin. Those of you who study physics, you know Kelvin. Kelvin argued against the extraordinary amounts of time required in Darwin's calculation of geologic and biologic processes. We are still, in the age of Darwin, maybe not convinced that the Earth at that point is only about 5,000 to 6,000 years old, but we're still working under the intellectual weight of the idea that the Earth is much younger than what Darwin and others have suggested, that these processes take longer amounts of time than people are willing to accept that humans have been around. As we move Darwin into society, move him into the public world, right? There are going to be debates, and in particular, we're going to get some debates at Oxford, and this is between Samuel Wilberforce, who is the Bishop of Oxford, he's an Anglican bishop, and T.H. Huxley, a philosopher. He, nicknamed Darwin's Bulldog, will have a series of debates here at university, trying to argue creation versus evolution. So it starts here in 1860, very early. These are images from Vanity Fair. a publication that followed the debates, recorded the debates, and this is a publication. This is not a science journal. This is a popular journal that brings political and social issues to bear to the general public. So this was followed closely. This image you have here is a marker showing that on June 30th in 1860, Thomas Henry Huxley and Samuel Wilberforce and others debated Charles Darwin's Origin of the Species in the museum. So Darwin's approach, Darwin's theory, controversial in his own day, controversial still today. Darwin will die in 1882, buried in Westminster Abbey. Those of you who know London know that Westminster Abbey is perhaps one of the most impressive landmarks in London, one of the most impressive places of worship in London. Gregor Mendel died 2 years later, and his work, little read at the time, showed that traits were inherited in discrete units. Later we will call these genes. This discovery supports Darwin's theory, and it's just one of the pieces of the puzzle that will start to come together to support that theory. I throw this in because this is the marker for his burial place in Westminster Abbey, and you have over here to the right the marker Charles Robert Darwin, born 12 February 1809, died 19 April 1882. Very little note about anything to do with his groundbreaking theory. On the other side, just next to him, another scientist. This is Herschel. William Herschel, an astronomer, a explorer of the heavens, right? A follower of Newton, gets a very nice marker. He gets a quote from the Psalms. Something the stories will be told of the marvels generation after generation, right? He's famous because he developed telescopes. Amazing telescopes, very large telescopes to try to examine the heavens, and he discovered the planet Uranus. So he gets this amazing marker in Westminster Abbey because he discovered a tiny planet with extraordinary telescopes, exploring the heavens, marvels to tell, in a very empty space over here.